All right, let's compute this flux integral. Things will be getting a little harder. So our surface is this. Let's find the normal. For the normal, we want in the positive z direction, so let's move things to the left here. I have negative x squared minus y squared plus z equals 0. So I can do a normal by taking the gradient. That'll be negative 2x, negative 2y, and 1. And divide by the magnitude. So 4x squared plus 4y squared plus 1. So f dot n, right, we want our flux integral, oops, ds. That will equal, well, let's see, before I know what it equals, well, so go ahead and do it inside here. So the dot product will be z times negative 2x. Negative xy times minus 2y will be plus 2xy squared, and then 3 times 1. So plus 3. And we're dividing by this. So 4, I'll factor the x squared plus y squared. Actually, it's going to cancel in a bit. So it's this surface integral. Okay, so the flux integral is found by doing f dot the normal. Now I have a regular surface integral. For that, I'm going to need ds will be the square root of partial z partial x squared plus partial z partial y squared plus 1 dA. And for this surface, my partials will be 2x and 2y. So this will be square root of 2x squared plus 2y squared plus 1 dA. And that will just be square root of 4x squared plus 4y squared. Don't really need to factor because it's going to cancel, but put it there. It generally does cancel. So this integral is now going to equal, I can make it a d integral. And I can't really simplify too much here. Minus 2xz plus 2xy squared plus 3 over this square root. I think I'll unfactor. Times this. And now these cancel. I will do things in polar. So what does our shape look like? Well, it's a circular paraboloid. Oops. We want that part inside that disk. That makes it nice and easy for us to realize what our D looks like inside this disk of radius 5 here. So that'll be our D. So if I convert to polar, it'll be a little messy, but let's see, we're going all the way around, 0 to 2 pi. R will go out radially, 0 to 5. This will be, and these cancel, negative 2 r cosine theta. I forgot to do one step. For z, I have to put in what z equals for my surface. On the surface, z is x squared plus y squared. Right, so I have to sub in. You're only allowed the two variables there. I have to put x squared plus y squared in for z. And that'll be just then r squared when I convert it to polar. This will be plus 2 r cosine theta, r sine theta, quantity squared is y, and then plus 3, and then all that dr d theta. So this is 3 integrals. I can do either order. I'll do r last. So we got integral 0 to 2 pi got minus 2r cubed cosine theta d theta, and then dr. That's the first one. And then we have to do this other one. 0 to 5, 0 to 2 pi. This will be r cubed times 2. Sine squared cosine d theta dr. And then plus the third one is just 3. That one will be the easy one. Actually, well, in a way they're all easy, but I mean, I might as well do that now. It'll just be 3 times 5 times 2 pi. So let's see here. Oops, I forgot one thing. So not quite as easy as I made it. Let's see. So when I converted to polar, I need an r out here as well. So r, dr d theta. So that will actually be r to the 4th. And this will actually be r to the 4th. And so I actually have to do this integral. So this will be 2 pi. I'll do the theta first. I'm doing the 3 here. Integral from 0 to 5 of 3 r squared over 2. Whoops. That is the integral. Let's do that then. 0 to 5. So what's my answer going to be? Yeah, I'll cheat a little bit, but if you integrate cosine over one full period, you're going to get 0. So that'll be 0, and then it doesn't matter about r. So this will equal 0. A little hard. This one we can actually do the antiderivative. You get sine cubed over 3, but if you plug in your limits, you'll get 0 and 0. Basically, this function's negative the same amount that it's positive over this interval. It's going to give you 0. Again, you can easily anti-differentiate it. Sine cubed over 3. Plug in your limits. And then our last one here is 2's cancel. So we just get 75 pi. All right, that's that problem.